Okay, good day everyone. So for today, we have a problem walkthrough of the three items I gave you as your assignment. And hopefully the previous samples and problem sets were sufficient enough to get you warmed up for these three easy items. Let's begin. So for the first item, item 4-57, we are asked to determine the force about an axis between A and C. And we are here to express the result as a Cartesian vector. Again, we are asked to determine the moment of this force about an axis extending between A and C, and we are here to express the result as a Cartesian vector. So we're given also this diagram here, this figure here, and its following dimensions. We're already given the force vector in its Cartesian vector form, read as 4i hat plus del j hat minus j 3k hat on force. So here we go. And we're asked to determine the moment of this force. So for this particular problem naman, when we're being asked to determine the moment about a specified axis, if we're not given a specified axis, we can actually choose which axis of rotation. And all we have to do is just to identify the unit vector there. But the good thing we have a formula here. Recall our formula of getting the moment about an axis such that you will get the magnitude of the moment of this force by getting the product of the unit vector that you're supposed to rotate about, so in this case AC, multiplied by the cross product of position vector and the given force vector. And for this particular case, I already selected position vector RCV, since that is your moment arm rotating. That's probably the only rotating moment arm that I can connect to axis AC. Actually, there's another one. I can get the position vector uh, um, AB, but since it's still in the axis of rotation of axis AC. But for this case, why bother, since we're already given this particular dimensions of point C and point B. So now that we know what formula to use, all we have to do is just identify the unknown variables that we have. So that is UAC and position vector RCV. So let's start with UAC first. Unit vector UAC is just simply the quotient of the position vector RAC over its magnitude RAC. Okay. And here's a much more longer version of how we arrive with RAC. Normally it's just RC in other books, but I just wrote now the entire thing RAC. In other books, they don't write the first one because at point A, that it just so happens it's conveniently point A sits at the origin of our axis XYZ. So hence why some of the books don't even label your unit vector as such. It will be a different case if your axis of rotation is sabihin natin from this point here and here. In this case, it has a magnitude and that is 4, and then this one has also its magnitude here. It has value basically. So the only reason why they're not labeling it because at this point it's basically 0 coordinates. If it is at this point, it has an x coordinate and 0 y coordinate and 0 z coordinate. So in this case, RAC. So in this case, to get the position vector RAC, just simply get the difference between RC and RA. So let me just write that down just so that. So basically, this one is the other translation here. It's RC minus RA. You can check the notes from our previous chapters or check into the book on why is it that way. And then if we expand that, it'll be like something like this. So it's going to be 4 minus 0, 3 minus 0, and of course 0k, so 0k. And then you just get the you square, whichever the end result is, that will be 4i hat, that will be 4i hat plus 3j hat feet will be canceled out here. So all you have to do is just square it. I don't need to include the 0 here anyway, so I just want to show you guys. So that'll be 4 squared plus 3 squared, and then get the square root to get the magnitude of AC. And from that, you get now the unit vector, 0.8 I hat plus 0.6 j hat. These are unitless, by the way, so no need for the brackets there. The next one, the next variable that we need to determine is RCV. You can pause this video if you want to determine how using this as an example. So to get RCV, that means you have to subtract RB, position vector RB, with position vector RC. So coordinates of RB and the coordinates of RC. You can pause this video to try yourself on how to get our position vector RC. Okay. Just like I said, RCV vector is equals to RB vector minus RC vector. And this translates into, so we have X here. So both of them has a magnitude, as a coordinate of 4, 3, but with one difference. Point C doesn't have a Z coordinate, it's just 0, but B has a -2 since it's going down. So 4 minus 4, 3 minus 3 plus -2, it's already down, minus 0. So your ending result here is just -2 k hat. There we go. Okay, we already have unit vectors UAC. We have also unit vector, we also have the position vector RCV. All we have to do now is just substitute our known values now to this particular formula to get the magnitude of the moment of force. And the good thing, the force vector is already given. All we have to do is just lay it out just like determinant. So the only difference between the normal cross product from the previous one that we do is that instead of the first row as ijk, we align the values of the unit vector just like so. So 0.8, 0.6, 0. And then the next row would be the position vector, as we discussed. That's going to be 0, 0, -2. And then, of course, the last row would be 4, 12, and -3. And then from here, it's just a matter of expanding this determinant. Just be careful with the multiplication here. So 0.8, that's going to be 0 minus 3 minus a product of -2 and 12 minus, that's going to be 0.6 times, so that's 0 times -3 minus a product of -2 and 4. And then, of course, we have 0 here, so that means the entire thing, the entire matrix is going to be, the entire determinant is going to be 0. So it's 0 times 0 times 12, 0 times 4. Okay. And simplify further. And what you will have here is a full number. You will, in terms of pounds, we're pound force feet, since this is the magnitude of AC moment. This is the magnitude of the moment of force thinking about AC. Wait. There we go. Anyway, so there's a switch up on the animation there. So the final answer for the magnitude here is going to be 14.4 pound force feet. Unfortunately, that's not yet the final answer because we need to express it in Cartesian vector form. Fortunately, we already got the unit vector AC. So all we have to do is just multiply 14.4 with UAC, just like so. So 14.4 times 0.8 I hat plus 0.6 J hat will yield you 11.52 I hat plus 8.64 J hat. There's a J there somewhere. Okay, there's a J there na patungan. So that's 8.64 J hat pound force feet. Okay. So again, you may pause the video. If you want, you could try it again. Just try to solve it, analyze. And if you have questions, feel free to email me at my provided email address in your course site. And or feel free to chat me via Google Chats. Okay? The next item, actually the next two items are probably one of the easiest ones. So the sample ones And the problem sets are already provided to you are a lot harder to analyze if you're not used to getting the couple moments. Okay, so for couple moments, again, it is a couple mode because it has the same magnitude and they're parallel to each other, the same magnitude but opposite to each other, and they have a perpendicular distance that's linked in between them. In this case, 150 millimeter, 150 millimeter by the center, or basically that's 0.3 meters overall from one magnitude to the other. Okay, so all we have to do here is try to determine the couple moment produced. So here we have a man tries to open the valve by applying the coupled forces of F equals to 75 newtons to wheel. Okay, so the man is applying 75 newtons of force, coupled forces to the wheel. Problem was to determine the coupled moment that it will produce. Okay, so I've already provided you the final answer, so you have already a clue, but technically you don't need to find out because this one is a lot easier to solve. So here's the line, here's the given. And the solution here is pretty straight up. All you have to do is just apply the equivalent couple method, which is simply multiplying just like your ordinary moment. You get the moment, you get the magnitude of the force, multiply its perpendicular distance. So you determine the sign. If it's positive or negative, in this case, it's going to be negative because it's going to be clockwise. It's not counterclockwise. So it's going to be negative 75 newtons times 0.3. So the entire perpendicular distance. You can also do it individually. You can also do it force times 150 about the rotation of this axis, and then you can also do it. You would still yield the same thing. So in this case, the negative 75 times 0.3 will give you negative 22.5 Newton meter or 22.5 Newton meter clockwise. Okay. Okay. So you want to try this again, kindly pause and rewind the video and try to solve it on your own so that you can get some practice and some memory muscle in you. The last item is about a sample of simplification of forces and coupled moments. And like I've discussed, it is what it is. It's basically just simplifying multiple forces into one resultant force and identifying where the direction is and what's the total moment, basically the resultant moment. That's all about the topic behind simplification of forces and coupled moments. And it's just so happens sometimes that for any given problem, there's an additional moment that you have to consider other than the moments that the force generates. Okay? So I think I've already provided enough example for you there so that there's a lot of variety that you can go back from, and you can also refer to the book because the book is pretty much can show you. It already shows you step by step on how it's being done. I just put some animation into it so that it's a lot easier to understand. Okay, so for 4-100, we are here to replace the force system acting on the beam by an equivalent force and coupled moment at point B. So let's see, from point A to B, we have 3 kilonewtons. We have 1.5 applied at 30 degrees from the y-axis, and then 2.5 kilonewtons applied at this particular slope triangle ratio. Here's the dimensions in between supports. Okay. I already provided you the answer here, so that it's a lot easier to grasp what the how. So all we have to find out here is how you solve it. Okay. So essentially, you're gonna find the resultant force, the theta, and the moment resultant. Okay. In this particular case, the moment resultant at point B. So we're being asked at point B. Okay. So the first step here, okay, you write down your solution, and the first thing we got to do is, of course, we have to get some force summation. And remember, the force resultant is equal to the square root of the sums of the square of the x and y component of our respective force, just like so. So what are those? In this particular case, the positive is going to the right, going up is positive as well. Going to the left is negative. So for resultant force X is equals to the summation of the X forces, which is equal to, let's start with 1.5. That's 1.5 kilonewtons sine 30 degrees. So we're referring to that. Hope at this particular stage you're not confused. So, and there we go. Let's just put that again. So let me just draw that for you. Here's the triangle. Here's the angle, which is 30 degrees. So this is the 1.5. So this is 1.5 sine 30 degrees, which happens to be in a horizontal position. And then this one is the downward position. This is 1.5 cosine 30 degrees, but we'll get to that later. Okay. All right. And then next up is 2.5. This one's a lot easier since we dealt with this kind of problem before. So all you have to do is just multiply 4 over 5 to get the horizontal distance here, but it's going to the left. That's going to be minus 2.5 times 4 over 5. Okay? And you would yield negative 1.25 kilonewtons, or as the book will describe to you, 1.25 kilonewtons to the left. We don't normally do this now. I just prefer the negative or positive signs na lang, okay? Then we do the same thing for vertical forces when direction going up is positive. So in this particular case, summation of Fy is equals to negative 2.5 minus 1, negative 2.5 times 3 over 5 minus 1.5 cosine 30 degrees, and then minus 3 kilonewtons. Good Lord, all of them were negative. So that gives you about negative 5.799 kilonewtons downward. Negative. So since now you know the Fr sub X and the Fr sub Y, you can now get the resultant force. You just square them and get the sum and then get the square root. You will have 5.932 kilonewtons. So that's one of our final answers. So the next question is, at what angle is it being applied? So all you have to do now here is basically you just get the tangent inverse and you will get 77.84 degrees from the negative x-axis. Next here is the moment summation. And all you have to do lang dito is just get the moments at point B plus other couple moments that's available. But in this case, there's none, so we cancel that out. So we're summation of moment at B. And what are those force moments? So that's gonna be 3 kilonewtons, so that's gonna be canceled out, 0. That's gonna be 1.5 cosine 30 degrees counterclockwise here. So times 2 meters, and then we get 2.5 times 3 over 5 times the total perpendicular distance of 6 meters. So there we go. That will give you 11.59 or 11.6 kilonewton meter counterclockwise. So last but not the least, you visualize by drawing a diagram. So the sum forces should look around like this one. At point B. Should have drawn the diagram here, but that's fine. The structure as well. Okay. So that should probably conclude the walkthrough, but if I may add a few more notes, the application of the simplification of forces will travel all the way down to your equilibrium of rigid body, because notice we're just knowing what are the moment of force what are the forces acting on what are the resultant force, but we haven't considered the reactions at the supports, and that is something that we will be discussing on the equilibrium of rigid bodies now. Okay, and that is the only time that we're going to equate the summation of forces of X and Y into 0, or the moments about a particular point equals to 0. So that is the next topic. Okay? But before that, we're gonna be discussing lecture 4.5. Okay. So I hope you finally understood the lesson behind this. And if you have questions again, feel free to reach me out on my provided contacts, and then try to rewind the video and solve it on your own if you haven't gotten it, and then try to pause it and try to solve it on your own. With that, thank you so much.